class, this is actually our second class on stochastic processes. Okay? Now, a quick recap on what we have done for those watching from wherever you're watching in the world, and for those of us in class here. What did we do in the first class on stochastic processes? If you read through your notes or you watched that video, you should be able to say these things I am saying. Number one, we started that class with telling ourselves that if you don't want to call it stochastic process, you can call it random process. Because a stochastic process means, that word stochastic means what? Random. Is it clear? So when you say stochastic process, another name for a stochastic process is what? Random process. Since stochastic means random. Is it clear? So that was the very first thing we said. Now, after doing that, I told you in that class that it was not sufficient to say, now that we know that stochastic means random, it is not sufficient to say a stochastic process is a random process and end the definition there. Is it clear? I told us there is need to actually understand the statistical or mathematical definition to what is called a stochastic process. Based on that, we now define a stochastic process as a collection of random what? Variables. Is it not so? That are indexed in some mathematical set or with some mathematical set, such that that mathematical set is especially interpreted as what? Time. Is it clear? Now, in that same class, I told you I like explanations, especially when explanations would make you understand the essence of that concept. So when we say it's a collection of random variables indexed in a mathematical set interpreted usually as time, what were we actually referring to? Now, I said for you to understand in detail what we are referring to implies that one needs to know how different a stochastic random variable is from a random variable. So if you say stochastic random variable and a random variable already, previously we had defined a random variable as what? A real valued function. Is it not so? What defined over a probability space. It means, it sounds funny, but it means that you can say a stochastic random variable is a random variable. Do you understand what I'm saying? Now, looking at it from that angle, there should be a difference between a stochastic random variable and the ordinary concept of a random variable. And I told you that where a stochastic random variable comes in, hence giving rise to the concept itself of stochastic processes, is the fact that stochastic processes handle a collection of random variables because it describes or models a situation that is rapidly changing. You get me? Such that, okay, look at it in this instance. If you consider how molecules of what do you call it, a gas move. In physics, we were told that matter can take 3 states, right? Solid, liquid, and gas. One thing we were told in physics is that as you move from state to state, the stability of molecules become what? Haphazard. In the sense that in the solid state, molecules take on a particular structure and they are more stable. But in the liquid state, they become less stable compared to what? The solid state. However, in the gaseous state, they are more random. Do you understand me? Now, they are more random, and the kind of movement stochastic processes study is not the movement of particles in their solid state or in their liquid state, because there is less randomness in such state. It is rather the movement of particles in their gaseous state. Because if you consider how random particles move per unit time, you will see that in each time interval, their movement is very, very sporadic, very, very random. So if you move from interval to interval, the particles keep changing. Do you understand me? The movement of the particles is so rapid, they keep changing. And that is the application or the essence of stochastic processes. If you want to model a situation where what is involved is the solid state, it is not a problem. Certain aspects of statistics can study that. If you want to change state from solid to liquid and you want to do some modeling there, certain aspects of statistics can study that. But when you want to dedicate your effort of analysis to a case where randomness is very, very high, especially from interval of time to interval of time, the best suitable technique is what? Stochastic process. And depending on how you view it, you may also come from the angle of what? Time series, as we discussed in yesterday's what? Class. Is it clear? Because the particles, they change with respect to what? Time. That is one thing common to both of them. However, the level of randomness is what makes stochastic process, the study of stochastic process, different from what? Time series. Okay? So, based on that, we now moved on to the next item in our discussion. I made mention of how one should perceive a stochastic process. And I said that one can categorize a stochastic process from different angles. Did I mention that in this class? Did I? I hope I'm talking to people. Good. Now, and I told you that there are some questions that people ask you, such that when they ask you those questions, you will be wrong to quickly supply an answer, because the answer to that question you have been asked is a question on its own. Do you understand me? So when you are asked such a question, they expect you not to answer, rather to give your answer as what? A question. And I gave you a good example. If someone comes to you and say, what type or categories of stochastic processes are there? And please, I would want to pardon my error. Should I confuse category and type interchangeably? If I use it interchangeably, please pardon me, but understand where I am coming from. There is a difference in our study of stochastic process between categories of stochastic processes and what? Types of stochastic processes. Is it clear? So I may mix them up, but understand the essence is not the language, understand the meaning. Now, if somebody tells you, could you categorize what categories of stochastic processes are there? The answer to that question is not to say category A or category B. Do you understand me? Should someone ask you that question, the answer to that question should be, from what angle are you viewing the stochastic process? Do you get me? That is the proper answer to that question. Simply because, depending on the angle you are looking at a stochastic process from, it will have different categories. So, and I made mention of that in the last class, that if you want to categorize a stochastic process, one angle from which you can view a stochastic process for categorization could be the index set. So, do you really want from me an index set based categorization? That should be the question, which is an answer to the question that was asked you. Okay? Or if not an index set based categorization of stochastic processes, do you want me to categorize a stochastic process coming from the angle of the state space? And the person will now tell you, okay, go ahead. And thereafter, you can now give the categorization. Or do you want me, if not from the index set angle or from the state space angle, do you want me to categorize a stochastic process from their dependency, the dependency that exists between the random variables? You remember we said a stochastic process is what? A collection of what? Random variables. So it means that in that collection, there are several random variables. Now, if the random variables in a stochastic process are dependent on one another, it gives rise to a property or a consideration with which you can categorize the stochastic process. So do you want me to categorize it from that angle? That will be your answer to the question asked. And if the person now says, go ahead, that is when you can now give the categorization. Is it clear, everybody? So I remember we mentioned that in that class. Then, based on that, we started the classification, and I told you we are going to consider two, being the index set classification and the what? The state space classification. Is it clear? Now, starting with the index set classification, I told you that every stochastic process is a time-dependent process. Do you understand me? Because the particles change with respect to what? Time. If time is considered as the index set. Now, I said that if you are classifying a stochastic process based on the index set, it gives rise to a set of what? Classifications. One of them is the discrete time what? Stochastic process. And when does the discrete time stochastic process come up? It comes up whenever the index set comprises numbers that are drawn from the natural number system. Or from what? The integer number system, or are what? Countable in nature. Do you understand me? In other words, put it summarily, if the index set comprises numbers that are what? Discrete in nature, that particular what do you call it? That stochastic process will be called what? A discrete time stochastic process. However, your index set, if you call your index set capital T, your index set could also comprise elements, small t's, that are drawn from what do you call it? A continuous set. That is within an interval of values, or from generally just say the real line. For instance, if I tell you that I am picking a number from the real line, if I say pick a number between 0 and 1, that is, if I tell you to pick a number that I have a number x, okay, let me put it in set form. So I have R as a set, and I say R is the set of all elements x, such that x is a what do you call it? Okay, let me call this A rather. X is a member of R, and x, and 0 lies between x lies between 0 and 1, exclusive. I now ask you, what are the values of x? What would the answer be? On what? Uncountable. You see it. But if I restrict this set now, if I restrict this set by writing B is the set of all element x, such that x is a member of the natural number system, and x lies between what do you call it, and 1, what would you tell me? Is there any natural number that lies between 0 and 1? So this set will be what? Empty. But if I change this and put here 2, it will be a singleton. You see it? So now, if your stochastic process is considered from the angle of what do you call it? From the angle of the index set, such that the index set are a set of values drawn from the natural number system, countable system, you would say that the values are what? The stochastic process is what? Is discrete time. But if it is drawn from a set like this, your t values, if these are my t values, and this is the set T, capital T. This is my index set. And I'm taking my t values. All my t values are members of T. I hope you know. And in particular, being members of T, they are drawn from what? R. Then these t values will be what? Continuous. Hence, giving rise to what is called what? A continuous time stochastic what? Process. Is it clear, everybody? So those are the things we discussed, and we stopped there. We were not done. Let's now proceed to rounding up our discussion. So please continue that statement, everybody. The time says 12 o'clock on the dot. Please, by 12:10, I'll round up, because what I want to say is not that much. So 12:10, 12:15, we are done. I hope you can endure to that time. Thank you very much for your understanding. Okay, so now paragraph, everybody. It is important to note that if capital T, it is important to note that if capital T represents or denotes, Anastasia, is that your black marker? Okay, may I use this one? So it is important to note that if T denotes the index set of a stochastic process, with elements T that are members of N, then it is that are members of N, or T's that are members of I think Z represent, we use Z to represent the integers, right? Or I. I like using I. So let's include I or I. Then the stochastic process is what? Discrete. So this is another way of stating the same thing. Discrete time. But if T's being members of T, if for all T's being members of T, T is a member of R, then the stochastic process is a continuous what? Time stochastic process. As an extension of this notion, we note that T may be members of R2. What's R2? What's R? Now that I'm incorporating R2, what would you call it? I think you guys are doing real analysis. What would you call R2? Now that I've mentioned R2 in relation to R. I know that R will be the real numbers, right? The set of real numbers. Once I have brought in R2, it means that R should be perceived as a real line. You understand me? And that will now mean that in R2, this is what? A Cartesian plane. T. This is a Cartesian plane is formed when you put two real lines perpendicular to one another. Okay? So if this is one real line, this is R. If I was considering only R, I would just be considering a real line where the real line is partitioned into two by what? 0. And you now have to one side positive infinity, to the other side to negative infinity. Now, if I cross this real line with another real line to form the x-axis, the same thing happens, and provided they are at what? Perpendicular to one another, then it will give what? This is R2. So R2 is a Cartesian what? Plane. Is it clear? Anything above R2 is considered a hyperplane, otherwise called a Euclidean what? Space. Is it clear? So it is important to know that as an extension of the notion, what notion are we talking about? The notion that T can be taken from what? The real line. Or it can be taken from each of these systems. It is important to know that it can be taken from what? R2. Okay? Or the Euclidean what? The Euclidean or the Euclidean space, or what? Hyperplane. Okay? In which case, the stochastic process, formally considered as a random function, may now be called a random field. Is it clear, everybody? Now, what it means is this. One name. What are the names to a stochastic process? One name to a stochastic process is the stochastic process itself. Another name is what? The random what? Process. Is it clear? We use that word random process because of what I've told you. The word stochastic means what? Random. However, based on how it relates, based on the relationship or the characterization of what is called a stochastic process, especially when it is in the real line, okay, or in the natural number system, or what, in the integer number system, we call it a random function. Is it clear? I want you to note the difference. We can call a stochastic process what? A random function. However, if it so happens that your t's are no longer taken from R, or taken from I, or taken from N, but they are now taken from a Cartesian plane, or they are taken from a Euclidean space or hyperplane, you no longer have the right to be calling that stochastic process, which occurred in a space, not in the real line now. You no longer have the right to be calling it it's just any stochastic process or a random function. Because it is now in a space, it should be properly called what? A random field or a stochastic field. Is it clear? So the word field tells you that it is now occurring, the randomness that you are trying to observe or discuss or analyze is now occurring what? In a space higher than what? The real line. Is it clear, everybody? Good. Now, paragraph, everybody. A stochastic process, paragraph, please. I hope you are putting that in a paragraph. A stochastic process may be categorized based on its state space. Now, question is, what is the state space of a stochastic process? I'm not saying you should write the question. No? I'm saying that a stochastic process could also be classified based on what? The state space. Is it not so? So, in that instance, what can we now say? Please read that statement again for me, the last statement you've just made. In terms of what? Is state space, comma, where the state space of a stochastic process, comma, where the state space of the stochastic process are the values assumed by the random variables of that stochastic process. Are the values assumed by the random variables of that stochastic process. Are we there? If the values, continue the statement, if the values in the state space are discrete, if the values in the state space are discrete, among several, what do you call it, names, if the values in the state space are discrete, comma, among several names to call such a stochastic process, comma, the stochastic process is called a discrete space stochastic process. And that tells you that there are other names which you can actually give to what? The stochastic process. But what matters is an understanding of what is actually going on. However, if the values in the state space are from the real line, if the values in the state space are from the real line, such a stochastic process may be considered a continuous space stochastic process. Among other names it can be called, may be considered a continuous space stochastic process. Among other names, it can be called. Full stop. Are we there? May be considered a continuous space stochastic process, comma, among other names, it can be called. May be considered a continuous space stochastic process, comma, among other names, it can be what? Called. Full stop. Are we there? Eh? Read your statements to me from the place we started. Read your statements aloud. Let me hear. Okay. Okay. Because the values in the state space are what? Discrete. Okay? And take note, there are other names to call it. You get me? Now, however, if the values in the state space are what? Continuous. That is from the real line. Then the stochastic process may be called what? Good. Among other names, it can be called. Oh, money in my head. Welcome. Let's stop here. Let's stop here. So thank you very much for listening. God bless you all. I'll see you in my next class. Okay? Thank you.